This edition of Where Did the Road Go is sponsored by Tim, Allison Cook, Eric Hervin, and Super Inframan. If you want to learn how you can sponsor the show, go to wheredidtheroadgo.com. And now our show.
Transmission start. Welcome to Where Did the Road Go? Join us as we wander off the path and explore lost history, consciousness, the paranormal, unexplained mysteries, alternative thought, and much more. We are present on the web at wheredidtheroadgo.com. Now here is your host, Seriah.
Welcome to this edition of Where Did the Road Go? Tonight I have with me the Snake Brothers.
Glad to be here. Yep, thanks for having us, man.
And I've been kind of saving this because I wanted you guys on this. I wanted to do a news show, particularly oriented more towards space news. And I've been collecting a bunch of it, and you guys were the perfect ones because you usually do a space news segment every show.
That's right. Space Weather News is our shtick.
So let's jump into a few of these. This one was kind of it's posted on Fox News. It's kind of interesting, but it's not new to most of us. Giant asteroid strike 13,000 years ago had global consequences, shocking study says. And it says that the research published in the journal Paleontology or Paleontologia Africana suggests an asteroid strike with global consequences occurred 12,800 years ago. This devastating strike caused mass destruction, wiped out many species of animals, and led to climate change during an episode known as the Younger Dryas.
Which asteroid strike are they talking about?
They don't say.
Okay. So they're just talking about maybe some of the proxy evidence that's been found?
It says, we seriously need to explore the view that an asteroid impact somewhere on the Earth may have caused climate change on a global scale and contributed to some extent to the process of extinctions of large animals at the end of the Pleistocene after the last ice age.
Yeah. Okay, so they're talking about the proxies.
Yeah. So I don't know what the difference there is.
Well, they don't have a crater necessarily. They're looking at
sediment layers.
Oh, okay.
So sediment layers, the YDB or the Younger Dryas boundary layer, which is sort of similar to the Cretaceous Tertiary boundary layer that the one where the dinosaurs all died. It's a thin layer of material that doesn't match anything above or below it, and it's full of what they call impact proxies, which are like nanodiamonds and melt glass and stuff that
indicating things were really hot and on fire.
That's right.
Okay, all right. What I find interesting, though, is it's actually on Fox News. I mean, this is stuff that people like Randall Carlson and Graham Hancock have been saying forever.
Yeah.
Yeah, that's pretty amazing.
It's really cool. So it's in the mainstream there.
Yeah.
When was that story? What's the publication date?
This was, I'm going to have to pull up the original. I save everything in the Pocket app because it's easier.
Okay.
October 7th.
2019, probably?
Yeah.
Okay, yeah.
Well, I assume so. It doesn't say, so I'm assuming it means published on 2019.
Yeah. Kyle does this to me, too. He's like, when was that story published? I'm like, I'm looking for the date.
Sorry.
It's important. The second part of it says, near-Earth objects could be used by extraterrestrials to watch our world. Stunning study suggests. And immediately it's like, wait, what? And it says the asteroid strike, which was officially verified in Greenland in November 2018, left a 19-mile crater and may have caused the disappearance of the Clovis people, a mysterious prehistoric group that vanished without a trace, according to The Sun. Yeah, because that's the only source you can cite is The Sun. The crater was first discovered in July 2015, but it took until November 2018 to confirm its source. According to NASA, the massive hole is one of the 25 largest impact craters on the Earth and said to have rocked the northern hemisphere. There is some evidence to support the view it might have possibly been the very place where a large meteorite struck the Earth 12,800 years ago. If this was indeed the case, there must have been global consequences. I have no idea what this has to do with extraterrestrials.
Is it talking about just extraterrestrial material?
Maybe.
Like comet itself or the
I
impactor?
thought it said something about watching.
Yeah, it says near Earth. I see. That's a link. Oh, I thought it was the title of the section. That is not written like it should be.
Tricksters.
So now I'm clicking on that one.
Okay. Well, yeah. So they're talking about the Hiawatha crater there. That's the Greenland crater that they found beneath the Hiawatha Glacier.
It does great things for people.
And I know that, like, if you go on Wikipedia or other places to look at it, they give a time range of between 3 million years and 12,000 years ago for that impact. But the interesting thing there is that the Greenland ice sheet, in most cases where they've done ice cores, they drill all the way down to the bottom to hit the dirt, and then they have this long core where they can count the years. In most cases, the Greenland ice sheet can be up to like 150, something like that, 150,000 years old, down at the deepest layer. But in the Hiawatha area, it's only got about 13,000 years of ice on it.
Oh, okay.
Undisturbed layers
of ice, implying that something destroyed the ice sheet there around that time. So it kind of is. It's not a complete date for that crater, but it's interesting. So,
all right. I mean,
tell us
again, it is kind of what tells about what the extraterrestrials.
Yeah. I want to hear about the aliens now.
So it talks about how we have a lot of asteroids and stuff floating around the Earth, and it says these near-Earth objects provide an ideal way to watch our world from a secure natural object that provides resources an extraterrestrial intelligence might need: materials, a firm anchor, and concealment.
Yep.
I guess that's not untrue, but that doesn't. It's not supported by any evidence.
Nor is it in any way connected to the Hiawatha crater, which I don't understand why those are in there in the same place. But
yeah, well, it probably just
going to spot.
What was
if
that?
If I was going to spot an alien world, I'd probably set up base on one of their asteroids.
Hide behind rocks.
Yeah,
been doing it for thousands of years.
All right, let's see. We have we got this one. El Pital, a massive ancient port city home to 150 pyramids. Are you familiar with this?
Which city is it? Sorry, we lost you there.
Oh, wow. I just got so many pop-ups. Hang on. Et El Pital, Elpital.
Where is it?
I'm looking.
The pyramids.
North America's largest coastal city around 1,500 years ago. That comes from the National Geographic Society. Dubbed El Pital due to the vicinity of small town of the same name, archaeological surveys revealed that this sophisticated ancient port city was the home of hundreds of pyramids. Excavations eventually revealed as many as 150 earthen pyramids, as well as countless buildings, some of which were more than 100 feet high. The ancient city lies around 100 kilometers northwest of the modern-day city of Veracruz. Its discovery helped experts understand the impact the ancient city might have had in trade, migration, and development among other pre-Columbian civilizations in the Gulf of Mexico.
It's in the Gulf of Mexico. I was looking it up here. I haven't heard of that. So, but it's earthen pyramids, like earthworks.
Yeah, it looks that way. And most of them are covered by trees and stuff now.
Okay. Let's see.
Is this El Salvador?
No. He said North America, didn't he?
Yeah. The city of El Pital was massive for that. Just look up Veracruz. It's right next to that. The city of El Pital was massive for that period, and archaeologists have calculated that more than 20,000 people most likely called the city home around 1,500 years ago. This population density is unlike anything that preceded or followed it until the end of the 20th century, archaeologists revealed. This suggests that something special was going on technologically at El Pital that allowed it to flourish the way it did.
In pictures now, I see a bunch of earthen pyramids. It's very interesting. Yeah.
Crop
Did
fields.
not know.
Crop fields around El Pital were advanced and made highly productive by what experts consider some of the largest terraforming projects of the time, where the ancient inhabitants of El Pital dug extensive canals to drain wetlands and to channel water into fields that would have been otherwise unable to sustain crops. According to archaeological study, many crops are thought to have come to the Mississippi Valley through trade around the same period when the ancient city of Port El Pital flourished, suggesting that the ancient settlement near present-day Veracruz may have played an important role.
So what's the time frame? They're saying this
1,500 years ago.
Okay. Yeah, that's interesting. They were kind of 1,500 years ago. That would be just before the Pueblo civilization started up too, right?
Yeah, I think that was 600 to like.
Okay, so similar
13.
time frame. Yeah.
Yeah.
So it's interesting.
Yeah.
Just more stuff. I just sent you guys that on Slack. It's a fairly lengthy article with videos and stuff like that on it, and that came from Curios. I'm not sure how to say that.
.com.
It's Curiosmos.
Yeah. Curiosmos is what I call it.
Oh, okay. That works.
Most curious.
So yeah, that would have been around the same time as the cathedral building.
That's right, and the Pueblo civilization's over here. I wonder what the pyramid ziggurat things had to do with like agriculture, because it looks like the pictures we're looking at looks like farmland with pyramids in it.
Yeah,
interesting.
And those wouldn't have been
perfect for growing weed, man.
Well, what if the pyramids are much older than the farmland?
That's probably right.
You know, and they just got built over farmland because people didn't use them the way they were intended for use eventually. It was, lost technology.
Yep, settle in the same place where the pyramids are. People always live in the same places. So.
And that's why the evidence disappears.
That's right. Yep. It gets covered over by intrusive evidence.
So I feel like this one may have been altered as this is from November 12th. A star ejected from the Milky Way's heart of darkness has reached a mind-blowing speed. And I think there was a follow-up to this saying it was not what they thought it was. Are you guys familiar with this one?
I'm not sure.
This is the object they saw coming out of the center, towards the center of the galaxy.
Yeah.
Is that what it was?
Yep.
Yeah, I did see that. I don't remember a follow-up. What did they say about it?
Well, it says, as humankind's ancestors were As humankind's ancestors were learning to walk upright, a star was launched from the supermassive black hole at the center of our galaxy at a staggering 3.7 million miles per hour. 5 million years after this dramatic ejection, a group of researchers led by Sergei Pasov of Carnegie Mellon University's McWilliams Center for Cosmology has spotted the star, known as S5HVS1, in the crane-shaped constellation Grus. The star was spotted traveling relatively close to Earth, 29,000 light-years away, at unprecedented searing speeds about 10 times faster than most of the stars in our galaxy. The velocity of the discovered star is so high that it will inevitably leave the galaxy and never return, a researcher at the University of Oxford had said.
Did it make its closest approach to Earth about 100,000 years ago? Because we did.
It doesn't say.
Yeah, I think that was a different one. That one came really close. Yeah,
that was like in the Oort cloud or something.
Yeah, that one came in between us and Alpha Proxima.
Yeah.
So this one is farther away than that, but it's moving really fast because it got slung around the black hole at the center of the galaxy. They think.
Yeah, if there's a black hole there at all.
Something is there that slung the star quickly.
Yeah.
And so now it's on an escape velocity from the galaxy. That's the idea.
Yeah. Seeing the star is really amazing, as we know it must have formed in the galactic center, a place very different to our local environment. It's a visitor from a strange land. While the main science goal of S5 is to probe the stellar streams disrupting dwarf galaxies and global clusters, we dedicated spare resources of the instrument to searching for interesting targets in the Milky Way and Viola, not Viola, We found something amazing for free. With our future observations, hopefully we'll find even more.
It's cool.
Yeah, that is interesting.
It's kind of crazy to think that this thing could form in the center of the galaxy and then be thrown out at escape velocity.
Yeah,
Right.
That's. I mean, it seems more plausible that it came from outside and then slingshot around.
Certainly possible. It's also possible that whatever's in the center of the galaxy actually created it.
Yeah, yeah. It's just,
could have formed in the accretion disk or something.
Well,
Get outta here.
I mean, not being a black hole. If it's something else that actually creates this stuff and spreads it around it.
New theory about centers of galaxies by Seriah.
I think it kind of fits with the electric universe idea.
Yeah, it does. You're right.
Because they have quasars creating galaxies, if I'm not mistaken.
Yeah. Yeah, and quasar, I mean, even in the standard model, quasars are supposed to cause star formation in nearby galaxies.
Right.
So,
yeah,
right.
I could see that for sure. Like the electric universe model using the like the filaments of what am I drawing a blank?
plasma.
The plasma filaments, like something going crazy in there and just accelerating this star out of the galaxy. So they have a whole different idea about gravity. It's all electrical as well.
Yeah.
So
Things are held together differently.
right.
And I mean, if you have a complex enough system with enough objects, there's going to be one that is affected extraordinarily as opposed to all the other ones. So it gets flung out or it gets sucked in or whatever.
All right. So the next one I had here was also black hole in the Milky Way. Scientists just found an impossible black hole in the Milky Way galaxy. New black hole search method has just yielded fruit, and astronomers believe they have found a stellar mass black hole clocking in around 70 times the mass of the sun. But according to current models of stellar evolution, its size is impossible, at least in the Milky Way. And again, I'll go with it's probably not a black hole. When you start looking through this stuff and look at what they're basing the fact that it's a black hole on, which they sometimes don't even tell you, they just tell you that that's what it is, you find that it's not like completely solid evidence. It's usually like gamma rays or X-rays that they're picking up and not seeing what they're coming from.
Okay, so they have a source for radiative energy, a source for radio like energy, and they can't see anything at the source, so they assume it's a black hole.
Right. Yeah, for a long time, they didn't know what it was.
Oh, okay.
And then they just kind of tagged black hole on it. So it says, okay, way back in 1783, English natural scientist John Mitchell, the first person to propose the existence of black holes, suggested that black holes may be detectable if they were orbited by something that does emit light, such as a companion star, which would be tugged around the resulting binary system's mutual center of gravity. This is now known as the radical velocity method. It's one of the ways we search for and confirm existence of hard-to-see exoplanets as they exert a small gravitational influence on their stars. It can be used to find other invisible things, such as black holes. Liu and his colleagues were using the Large Sky Area Multi-Object Fiber Spectroscopic Telescope in China to search for these wobbly stars and got a hit on a main sequence blue giant star. But it took follow-up observations using the powerful Gran Telescopio Canarias in Spain and the Keck Observatory in the U.S. to reveal the amazing nature of what the scientists had found. The star, around 35 million years old and clocking in around 8 times the mass of the sun, is orbiting the black hole every 79 days on what the researchers call a surprisingly circular orbit. There has been another black hole of similar mass range detected, clocking in around 62 solar masses. It was created as a result of a collision between two black holes in a binary pair. The first... Hang on. There we go. The first direct detection of gravitational waves ever made by humans. It's not in the Milky Way, but it does offer one such way a black hole could form. I'm not aware of them actually detecting gravitational waves. Are you?
Oh. Yeah, the LIGO project, and it was
what was that?
It was called the LIGO project.
Okay.
They got a bunch of Nobel Prizes for detection of a wave-type disturbance after the collision of two black holes with, what was it,
30 solar masses.
30
or
solar
something.
masses. So they had built this enormous machine attempting to detect disturbances based on these kinds of events, and one happened, and they detected something. It moved the laser. It's a laser shooting down a very long tunnel, and supposedly when the waves come past, it moves that detection plate at the other end of the tunnel from the laser, and they were able to detect that movement as the waves came by. And so that was a pivotal moment in gravitational science. But it isn't necessarily gravity waves. It's waves caused by a gravitational event, I guess you could say.
Right.
They call them gravitational waves, but it's
Right.
not actually gravity.
Yeah, it's not gravity. Yeah. It's a fluctuation of space-time or
Yeah.
something.
Okay.
Yeah.
Yeah.
This next one comes from CNN.
Wait, can we go back to this real quick?
Yeah, absolutely.
So what they were seeing, it sounded like what you were saying, is they were seeing an 8 solar mass blue giant star orbiting something.
In a 79-day orbit or something.
Yeah, so that's a really fast orbit for a star. And so I guess that's part of why they're thinking it's a black hole, because there's something there that this star is orbiting around, and it's going very quickly.
In a
they
very
can't
circular
see it.
orbit.
Right. And they can't see what it's orbiting, so they're assuming it's a black hole. I think that's the idea.
Yes. Yep. That is it.
Okay.
That's really cool.
That is cool. I mean, what I didn't understand was, did they explain why they think it's an impossible black hole? Like why 80 solar masses?
I think it's too big. The planet is 8 solar masses, I think. Hang on, I got to go back to the article.
The orbiting star is 8 solar masses.
Yeah, I believe so.
I thought-
So my computer's doing all kinds of weird stuff right now, so we got to hang on. There we go. 70 times the mass of the sun is the black hole.
70 solar masses.
Yeah.
Yeah.
And that's too big.
Too big for the Milky Way, yeah.
So maybe it's not a black hole, but whatever it is, it's got enough gravity to spin this star around.
Right.
It's like create a 79-day orbit
Yeah.
with a star.
It's flinging a blue giant
That's crazy.
around itself every 79 days. That's some serious whatever it is.
And this one is filled with ads. I love this. You try to read an article and ads pop up. And I love the ones that pop up before you can even start the article. It says, like this, please subscribe for more. It's like, I haven't read this yet. You haven't given me a chance.
Right. You've won a free cruise.
Hey, go buy a newspaper.
So this one is that the black hole, it's called the black hole that helps baby stars grow instead of destroying them. And this is from CNN. Astronomers made the discovery using NASA's Chandra X-ray Observatory along with other telescopes. They found the black hole at the center of a galaxy located 9.9 billion light years from Earth, and the galaxy itself has 7 galactic neighbors. Previously, scientists using another telescope detected an impressive radio wave transmission that originated from a jet of highly energized particles and stretched for 1 million light years. Following up observations with Chandra revealed that hang on. So I have this thing. I built a new computer. And when Audition is running, which is what I'm using to record the show, occasionally the monitors go black. And I haven't quite figured out why it does that now. So I'm reading and the monitor just goes black for like 4 seconds.
Technology hates you.
Clearly. It's a great computer otherwise. This is one of the few bugs I haven't quite worked out yet, because I don't think it's video card related, because it only does it with certain programs. Follow-up observations with Chandra revealed the black hole to be a source of the jet. Chandra can detect X-rays created by hot gas that swirls around black holes, and that's what I'm saying. They're seeing the X-rays that they're assuming are hot gas from the black holes, and that's how they're determining they're black holes. While black holes are known to devour everything caught within their gravitational pull, they also release highly energized jets of material that spit out particles at the speed of light. Chandra also detected a cloud of X-rays near one end of the jet, the remains from when a hot gas bubble was heated up by particles in the jet when they mixed with other matter. The researchers determined that the giant gas bubble expanded and actually moved across 4 of the neighboring galaxies. When the shockwave of hot gas moved through the galaxies, it would squeeze the cool gas within them. The interaction would cause more stars, which feed off the cool gas to form. The researchers believe star formation is 2 to 5 times higher in these galaxies.
Okay, so I'm going to have to ask you to go back again, but didn't you say that they said that this galaxy that this was happening in, the originating galaxy, was 9 billion light years away? Or is
9.9 billion light years.
That's really far.
Yep.
Really, really, really far to be picking out all these details. But I don't know. That's 9 billion light years away is far.
Just a bit.
Yeah. I mean, like, I've looked at, I don't know, maybe their equipment is really good, but I've looked at pictures of galaxies that are 6 to 8 and they're just little smudges.
Right.
You know, so to be able to tell all those details that they're talking about
through all the dust
that's between us and that galaxy 9 billion light years away. So I guess what I'm saying is that that's a very interesting idea, but the way that article states it as fact is probably misleading.
Yeah, and I think that's my biggest issue with some of this stuff is that it's all stated as fact.
Yeah.
And when you look at the actual data they're working with a lot of assumptions.
Yes, lots of assumptions, and I mean, like, yeah, you can look at something like that, and they're also looking at a frozen aftermath, right? Because these, you know, they're talking about some kind of X-ray pulse that spread out from the originating galaxy and then crossed 5 other neighboring galaxies. That takes a long time to happen, and they're looking at the remnants of it, and they're saying, oh, well, this pulse must have passed through these other galaxies and caused this extra star formation that we think is happening in these other galaxies.
Right, exactly.
Cosmology is assumptions.
Yeah.
Yes. Same with a lot of old archaeology.
Right.
Yeah.
Hang on. On top of the computer issues, I have a cat who is not taking no for an answer for attention. All right. So this next one is
you need a better bunker.
Well, now she's out of the room for the moment, so the bunker is secure.
All right, secure bunker.
And this is from Nerdist, and 89,000 degree Fahrenheit wall of plasma surrounds our solar system. Let's see. The sphere of piping hot plasma, which again is low density, meaning Voyager 2 can pass right through it without a problem, is discussed in the video from YouTuber and high school science, math, and computer science teacher Anton Petrov. In the video, which comes via Digital Journal, Petrov discusses one of NASA's latest discoveries made when Voyager 2 space probe, launched in 1977, began passing through a region surrounding our solar system known as the heliopause. In this region, Voyager 2 discovered the spherical wall of interstellar plasma, which Petrov calls a wall of fire. The wall of fire, Petrov notes, can be thought of as an actual physical barrier. That's what it says. Okay, that was my brain reading it twice. And it's almost like a wall of hot plasma and cosmic radiation that suddenly jumps up as soon as we cross into the so-called interstellar space. The wall of hot plasma ranges in temperature from 30,000 to 50,000 degrees Kelvin, according to a paper published earlier this month in the Journal of Nature Astronomy. In the abstract for that paper, the authors say that the very local interstellar medium, aka the wall of hot plasma, is variable near the heliopause and hotter than expected. The abstract also notes that the Voyager 2 observations show that the temperature in that region is 30,000 to 50,000 Kelvin, whereas models and observations predicted a very local interstellar medium temperature of 15 to 30,000 degrees Kelvin.
That's that's the some people. Sometimes I've seen it called the heliosheath or the heliosphere.
It's not. It's outside the heliosphere, I think.
Okay.
At least judging by the picture.
Okay. Yeah, there's an area where the outgoing solar flux from our sun is
finally overcome by the incoming
interstellar flux from all the stars around us and the greater galaxy, and that makes this like sort of barrier where they're canceling each other out.
So it has, the image has, our solar system, a termination shock barrier, followed by the heliosheath, followed by the heliopause, and the heliosheath is also the heliosphere, and then it goes into sort of a bow shock of plasma.
That's right, because the solar system right now is moving through an area called the local bubble, which is it's a very old supernova explosion. And so there's all that stuff out there too that the sun is running into, basically, or the outflowing material from the sun. So we're running through the local bubble, which is an old supernova explosion, and there's all this gas left over from that, and it's still very hot. And then of course there's all the incoming material from the rest of the universe, and that makes all these shock waves and stuff in front of the solar system. Interesting. There's actually some good pictures of other stars doing this, where they're moving through like a nebula, and you can actually see like a bow shock in front of them. So they've taken good photos of that. So interesting stuff.
So I wonder what happens when we get out of the local bubble. Like how would it change the
we'd have a lot more cosmic rays, for one thing.
Oh yeah, because they're being disrupted by all of that stuff.
Yeah. Huh. And it's again, I'm not meaning to harp on the whole electric universe idea, but the whole plasma thing fits in with that too. I mean, plasma is a big part of the EU, so
they're talking about actual kind of like CME plasma from the leftover junk from the actual star.
Yes. Yep.
Because the EU plasma is like electrical plasma, right?
Yes. Yeah. But it's also suggests that the sun is electrical as opposed to to a controlled thermonuclear explosion.
Yeah.
What
I
I'm
really
saying
like that idea.
What I'm saying is a lot of this stuff doesn't conflict with the electric universe idea, but it conflicts with ideas that we had following the standard model.
Right. The standard model is always being surprised by stuff that's out there, and in some ways, I mean, I think that happens to the electric universe guys too.
Yeah.
At the same time, they're able to predict stuff better in some cases than the standard model is. So
exactly.
Yeah. I personally, I think it's a combination of both.
Well, so do I.
I'm not ready to totally throw out the standard model, but I definitely think that the electric universe stuff needs to be included in large scale structures in the universe for sure.
And it's slowly being brought in under different names.
Yes, right.
And that's, to me, that's almost annoying. That's like, it's like watching Graham Hancock's stuff be confirmed, but Graham Hancock never being mentioned.
Right.
And then still
they still call him a pseudo-archaeologist or whatever,
right?
Even though a lot of the stuff that he was positing back in the day has been confirmed, and now they're saying it in their own headlines. So
I remember after the tsunami in Indonesia, they found a bunch of temples underwater that had been uncovered by the tsunami, moving between India and Sri Lanka. Is that the small island there? South of India?
Yeah.
Which is exactly where the old text said. Yeah. Exactly where the old text said these things were, and Graham Hancock kept saying, look, if we go out into that ocean, we're going to find these temples, and they were like, no, you're not. And then it uncovers them, and it's like, okay, so he just got vindicated, but I don't see anyone mentioning that.
Yeah, that whole story kind of disappeared pretty quick. I think the Indian people, that was Dwarka. It's a legendary city that their own local legend had said was out there in the water. So, very interesting stuff.
And I think the original said there were a number of them.
Yeah, there's supposed to be like 7.
Yeah, seven was the number coming to me too.
they kept moving inland and building another one as the waters rose.
Yeah. Which is not a crazy idea.
And that would have had to have been, after the Younger Dryas, right? When the sea levels started to rise. So.
Right.
Exactly. So this one comes from Futurism.com. NASA finds supermassive black hole birthing stars at a furious rate. And again, the idea of black holes birthing stars doesn't seem to fit with the idea of black holes.
Yeah.
It's surrounded by trillions of suns worth of hot gas and churning out 500 stars 500 times faster than the Milky Way. Galaxy clusters have been fascinating astronomers for decades, often consisting of thousands of galaxies. The clusters are the largest known structures being held together by gravitational forces. At their centers, astronomers have found some of the biggest and most powerful black holes ever discovered, and high-energy jets of extremely hot particles emanating from these black holes were found to be preventing the formation of stars, which of course raised a galactic mystery. Where are all the stars coming from? But now, thanks to data collected by NASA's Chandra X-ray Observatory and Hubble Space Telescope, a team of scientists has found a galaxy cluster called the Phoenix Cluster, some 5.8 billion light-years from Earth, is birthing stars at a furious rate. The black holes seem to be far weaker than other clusters' black holes, with trillions of suns' masses worth of hot gas cooling around it, allowing the formation of a vast number of stars. Usually black holes have kept these gases from cooling. Some of the words in here are wrong, so I'm slowing down as I correct their grammar, thereby stopping the formation of stars. By continuously spewing out high-energy jets of particles, the research could help us understand the life cycle of galaxy clusters and how the supermassive black holes at the centers interfere and sometimes seemingly aid the formation of stars within them. The paper of the results was published in the Astrophysical Journal last month.
I really don't understand about this black hole situation is how can light not escape the black hole, yet it's spewing out gas?
Right.
Okay. I can try to answer that.
Yeah, give me an answer.
I know the standard model idea.
Okay.
So a black hole has an accretion disk. Because the black hole spins, it flattens the stuff out that's orbiting it. And as you get closer to the black hole, as the edge of the disk approaches the event horizon of the black hole, it becomes more and more energetic. That's why they're saying usually these black holes don't allow the gas to cool, because the gas is spinning ever more energetically as it gets closer to the event horizon. And then the gas or the material that's actually falling into the event horizon is getting torn apart on the subatomic level. And because of all the spinning action there, it's basically a gigantic dynamo. So you end up with these twin jets that come out at the north and south poles of the accretion disk / black hole assembly. And those huge jets can be hundreds of thousands of light years long. They're highly energetic. They put out all the X-rays and gamma rays and everything. They're usually, and if they're really strong, they're called quasars. And those actually go out and hit other galaxies nearby and cause star formation. But that's the standard model picture of what's happening with that. So that's why they're saying it's spewing out gas.
So it's almost like it's the matter going in is being ripped apart to the subatomic level, and so
not all of it, not all of it ends up falling inside because there's a huge magnetic field. So some of it gets funneled to the north and south poles and then shot outwards as jets.
Okay. Some of the massless particles, they're not being pulled by their gravity. Right. I don't know.
Yeah, it's I don't know. It seems like they're finding things that don't fit, so they're coming up with explanations without re-looking at it from a ground level, Right.
I mean, you'd really have to go there and watch it to see what's actually happening. Yeah.
But you couldn't see it. It's a black hole.
You'd have to be standing at above or below one of the poles, and then you'd be able to see stuff.
Yeah, I think the idea is nothing's actually escaping the black hole. It's stuff that's being spun inwards that doesn't actually get sucked in. Yeah, that is being spewed out as the jets, highly energetic. So and traveling either light speed if they're quote unquote massless particles, or near light speed if they're massy particles. So
I think it would almost make more sense to think of a black hole as like a garbage disposal. Stuff falls in, it crunches it down to core elements, and then spits it back out along the poles.
Universal garbage disposals. I like that.
We'll just take this matter and break it down to its element and then spit it back out and let it do what it wants.
Right. It's recycling.
Yeah, exactly. This one from news.osu.edu. This is from Halloween last year. Scientists may have discovered a new class of black holes. I don't know why all these black hole stories have come across me, but that's what keeps happening. I'm guessing that because I've looked at a couple, it keeps, saying, look, more black hole stories.
Yeah, look at all these black hole stories.
And they're interesting. So black holes are important. Okay, let's see. New research shows that the search may have been missing an entire class of black holes they didn't know existed. In a study published today in the journal Science, astronomers offer a new way to search for black holes and showed it's been possible that there's a class of black holes smaller than the smallest known black holes in the universe. We're showing this hint that there is a population out there that we have yet to really probe into the search for black holes. People are trying to understand the supernova explosions, how supermassive black stars explode, how the elements were formed in supermassive stars. So if we could reveal a new population of black holes, that would tell us more about which stars explode, which don't, which form black holes, and which form neutron stars. It opens up a new area of study. Imagine a census of a city that only counted people 5'9" and taller, and imagine that census takers didn't even know that people shorter than 5'9" existed. Data from that census would be incomplete, providing an inaccurate picture of the population. Let's get down to what their thing is. Astronomers have long been searching for black holes, which have gravitational pulls so fierce that nothing, not matter, not radiation, can escape. Black holes form when some stars die, shrink into themselves, and explode. Astronomers have been looking for neutron stars, small dense stars that formed when some stars die and collapse. Both could hold interesting information about the elements on Earth and how stars live and die. But in order to uncover that information, astronomers have to figure out where the black holes are. And to figure out where the black holes are, they need to know what they're looking for. For years, black hole scientists knew they were all between approximately 5 and 15 times the mass of the Sun. The known neutron stars are generally no bigger than about 2.1 times the mass of the Sun. If they were above 2.5 times the mass of the Sun, they would collapse into a black hole. But in the summer of 2017, a survey called LIGO, the Laser Interferometer Gravitational Wave Observatory, saw two black holes merging together in a galaxy about 1.8 million miles away. One of those black holes was about 31 times the mass of the Sun, the other about 25 times the mass of the Sun. Immediately, everyone was like, wow, because it was such a spectacular thing, not only because it has proved that LIGO worked, but because the masses were so huge. Black holes that size are a big deal, and we hadn't seen them before. Thomson and other astrophysicists had also long suspected that black holes might come in sizes outside the known range, and LIGO's discovery proved that black holes could be larger, but there remained a window of size between the biggest neutron stars and the smallest black holes. Thomson and other scientists began combing through the data from Apogee, the Apache Point Observatory Galactic Evolution Experiment, which collected light spectra from around 100,000 stars across the Milky Way. The spectra, Thomson realized, could show whether a star might be orbiting around another object. Changes in spectra, a shift toward bluer wavelengths, for example, followed by a shift to redder wavelengths, could show that a star was orbiting an unseen companion. And for anyone who doesn't understand what the idea of redshift is, if something's moving towards us, it shifts toward the blue spectrum. If it's moving away, it shifts toward the red. There is some question whether that's completely accurate, but that is the general accepted science on redshift. So he was looking for stuff that might be orbiting a black hole. Then he narrowed the Apogee data to 200 stars that might be the most interesting. And the data crunching found a giant red star that appeared to be orbiting something, but that something, based on their calculations, was much likely smaller than the known black holes in the Milky Way, but way bigger than most neutron stars. After more calculations and additional data from the Tillinghast Reflector Aschel spectrograph and the Gaia satellite, they realized that they had found a low-mass black hole, likely about 3.3 times the mass of the Sun. What we've done here is come up with a new way to search for black holes, but we've also potentially identified one of the first of a new class of low-mass black holes that astronomers haven't previously known about, Thomson said. The masses of the things tell us their formation and evolution. They tell us about their nature. So basically, they're smaller black holes. Potentially.
That story seems like the answer to the question, how did they the previous story where they found this black hole and we're like, how are they finding these black holes? Apparently it's LIGO again. That's what the experiment we were talking about. So yeah, they found a new way to look for them. Yeah, by looking at stars and seeing if they're the blue shift and red shift. Are they orbiting some unseen companion? Right. And then if they are, they measure the mass of the star and then they try to figure out its orbit. And then they say, okay, so how massy does the object that it's orbiting have to be? And then, but it's interesting because there is a threshold there, like the whether a star that collapses becomes a neutron star or a black hole is a matter of surface gravity, right? And so you can calculate the surface, and of course, this is all I'm just wrapping standard model here, but the surface gravity. So if the star has a certain amount of mass, and then it runs out of fuel, so that its core collapses. If there's enough material there after the core is collapsed, and then there's a shockwave explosion, that's a nova or supernova. The material that's left over after that explosion, if the surface gravity is higher, if the surface gravity's escape velocity is higher than the speed of light, you have a black hole, right?
I believe so. Yes.
If it isn't higher than the speed of light, then you have like a neutron star or a white dwarf or something. White dwarfs are even less mass than a neutron star, but
right.
And then it's forever for them to cool. A white dwarf can be a neutron star. It just takes forever for them to cool down. They have to radiate their heat. Like, think of a ball of metal that's really hot. You just have to let it sit there and cool down for a long time before it's cold enough to touch. So brand new formed neutron stars can be white hot, and then after millions of years, they cool down and they become completely invisible, just about, unless they're spinning really fast, in which they're making and then they're a pulsar. So,
right.
So there is a threshold there, like, if you're just above the mass, a certain amount of mass, once it collapses, the surface gravity is higher than the speed of light, and then you have a black hole, according to the standard model. So they're trying to figure out what's the threshold there.
And I wonder if, in the same way that, the neutron star would cool down slowly, if it's just barely over the mass so that its gravitational pull is faster than the speed of light, can it become a black hole for a little while and then, say, cool down or radiate off some jets and then...
Yeah, that's a good point. I was just thinking if it was hot enough, it may start out as a really hot neutron star, and then as it cools down and becomes more dense, it may collapse into a black hole. Yeah. It might disappear. If it's right there at the threshold, that's a good point.
And, I feel like 100 years from now, we're going to look back at this stuff and laugh about how little we knew.
Yeah, I totally agree. Basically, folks, everything we're saying is wrong.
Yeah, basically. Yeah, but on all levels.
That's right.
This is the manual for how the universe works. Final edition,
updated daily.
That's right.
and I do think the EU stuff is going to eventually work its way in. It is slowly. I don't know if I clipped the article, but there was one about large scale structures being found in the almost like filaments in the galaxy, and I'm thinking, right, yeah, this is well known, and now science is finally saying this isn't gas. What is this?
Right.
And it's like, why don't you look at the electric universe and see what they've been telling you it is?
And you brought up the redshift, idea, and that is, there's a part of the electric universe model that I think they used Halton Arp's ideas about redshift, the intrinsic redshift, that it's actually this is fundamental to creation of matter. Yeah, and it begins something like that. Like, it starts out
with what it looks like a massive redshift.
Yeah,
yeah,
it's young matter.
Yeah,
right, and young matter it might be. I know there was something I read that said that redshift is actually a measure of speed. And they're basically assuming the universe is expanding in all directions, so the larger redshift is the stuff moving fastest away from us.
That's the standard model redshift.
Which it could be. I mean, that's basically the Doppler effect. The waves start out at a certain frequency, but if it's moving away from you, the frequency of the waves passing the observer are less frequent because the object emitting the waves is traveling away so fast, so that it's shifted downwards to a lower spectrum.
Mm-hmm.
But and I mean that seems plausible, but there may be other ways that things can be redshifted too, which is what I think Halton Arp was after.
Yeah.
You know, he was looking at the strange galaxies that seem to be like two galaxies that look like they're connected by a filament. One of them is highly redshifted. The other one is not as redshifted, but it appears that the highly redshifted one is in front of the other one, therefore closer to us.
Yeah.
And that goes against the standard interpretation.
Yeah. Yeah.
Like, first of all, they shouldn't be connected by any filament if one of them is billions of years older than the other one and much, much further away.
Yeah.
Right.
How can they be connected by this filament? But they clearly are.
Like I said, 100 years from now, we're going to look back and go, look what these people believed.
Hell, maybe next year we'll be looking back and laughing at ourselves.
Yeah, well, that could be too. So this one comes from livescience.com. Hoag's object is a galaxy within a galaxy within a galaxy, and nobody knows why. It says, look closely at the Serpent constellation slithering through the northern sky, and you see a galaxy within a galaxy within a galaxy. This cosmic turducken is known as Hoag's object, and it has befuddled stargazers since astronomer Arthur Hoag discovered it in 1950. The object in question is rare, a ring-shaped galaxy measuring some 100,000 light-years across, slightly larger than the Milky Way, and located 600 million light-years from Earth. In a recent image of the oddball object taken by the Hubble Space Telescope and processed by geophysicist Benoit Blanco, a bright ring of billions of blue stars forms a perfect circle around a much smaller and denser sphere of reddish stars. In the dark gap between the two stellar circles, another ring galaxy, much, much farther away from us, peeks out to say hello. What is going on here, and what tore Hoag's object in two? Astronomers still aren't sure. Ring galaxies accounts for less than 0.1% of all known galaxies, and so they aren't the easiest objects to study. Hoag himself suggested that the galaxy's peculiar ring formation was merely an optical illusion caused by gravitational lensing, a effect that occurs when extremely high-mass objects bend and magnify light. Later studies with better telescopes disproved this idea. Another popular hypothesis is that Hoag's object was once a more common disc-shaped galaxy, but an ancient collision with a neighboring galaxy ripped a hole through the disk's belly and permanently warped its gravitational pull. If such a collision occurred in the past 3 billion years, then astronomers looking through radio telescopes should have been able to see some of the fallout from the accident, and no such evidence has been found. If there was a cosmic crash at the core of Hoag's object, it must have happened so long ago that all evidence has been swept away, with only a handful of other known ring galaxies available to study, none of which show the perfectly symmetrical characteristics found in this one. Hoag's object remains a mystery wrapped in a riddle inside of an enigma, like a turducken.
It's a Russian doll. That's one of those things. Is that what you're talking about? Where you open and there's another one inside of it, and then you open that one and there's another inside of it.
Is that what it's called, a turducken?
I don't know. That's what I was asking. Is that the word?
No. The turducken is the turkey stuffed with like a duck stuffed with something else.
Yeah.
Turducken.
A chicken, a duck, and a turkey. A turducken. That's right.
That's a new one on me.
It was a popular thing for a little bit.
Yeah, I remember that. The idea of a ring galaxy is pretty strange too, because if the center was torn out by something else, but it happened so long ago that there's no evidence left behind, what is holding all of those stars in the ring?
Aliens.
Right.
Okay.
This is
There you go.
This is a Type 3 civilization building a ring galaxy.
How do they keep them together?
Why not?
It's 100,000 light years apart.
Yeah.
How do they know that each other are there to stay with each other?
Electricity.
Connected by a string.
Yes, electricity.
Yeah, there you go.
So this next one comes from CNN Wire. And I think you guys will know a little more about this one. Discovery near San Diego Freeway shows humans were in America 100,000 years earlier than thought. And it says, remains of a mastodon. I want to say Graham Hancock's new book talks about this. The remains of a mastodon discovered during a routine freeway excavation in San Diego shows there was human activity in North America 130,000 years earlier. I'm sorry, 130,000 years ago, or about 115,000 years earlier than previously thought. Paleontologists with the San Diego Natural History Museum discovered the remains of the ancient mammal more than 20 years ago, but it wasn't until now that scientists were able to accurately date the findings and possibly rewrite the history of the New World as we know it. The study to be published this week in the National Science journal Nature said the numerous limb bone fragments of a young male mastodon found at the site show spiral fractures, indicating they were broken while fresh. Hammerstones and stone anvils were also found at the site, showing that the humans had the manual skill and knowledge to use stone tools to extract the animal's marrow and possibly use its bone to make tools.
Yes.
Now, is this what Graham talks about in this book? Is this the story?
I think so. It sounds familiar. Like one of the bones or one of the tusks or something was actually sucked down into the ground, standing up.
Yep.
Yeah, I think so.
Like they had.
Is it the Seriah mastodon site? Is that one?
I don't remember the name.
Okay.
That sounds.
Yeah.
But yeah, I think you're right that was in his book, and if I remember correctly, like
that. The archaeological treasures found at the Seriah site will be on display at the San Diego Museum.
That's it. It's the Seriah mastodon site, pushes human occupation of the Americas back 100,000 years or more, and that's very, very controversial for the Clovis first model, which has been falling apart for the past couple of decades anyway. So,
and that's a lot of what Graham's book the new book talks about, is how the Clovis first model just doesn't work anymore.
Right. I mean, there's the Seriah mastodon site is not the only one. There's one that pushes it back to 20,000 years, BP, and there's quite a few. So, and then of course there's Huatlico down in Mexico, which pushed it back to 200,000 years ago. So,
well, I remember there was one book. I think it was the Atlantis Blueprint by Rem Flamath, was talking about how a lot of the oldest sites are found coming up from Antarctica, because he was suggesting Antarctica was Atlantis. And that, peopling of the Americas probably came from not only across the Bering Strait, but also up north from it, going north from Antarctica as it, shifted down south.
So the people that crossed the Bering Strait and then came down through the ice-free corridor were latecomers, was the idea.
Exactly, yeah.
Yeah, it's also possible that was before Atlantis.
Yep.
Yeah.
Like Atlantis is not necessarily the first civilization.
They were just an old advanced one, not necessarily the first peoples. Yeah. And that ice-free corridor wasn't there very long, so it doesn't give a very big window. You have to have the sea level has to be low enough to where you can cross the Bering Land Bridge so that it's not underwater, but the ice has to be not massive enough so that there's a corridor between the Cordilleran and Laurentide ice sheets, because you have to cross the Bering Land Bridge and then come down through the quote-unquote ice-free corridor to get into North America. And so that leaves a small window of time, and that's where they think the Clovis came from. The standard model does, but
yeah.
But then again,
even that doesn't
what
quite
Clovis
work.
remains do we have?
Right. Yeah. And Kyle's pointing out there's no Clovis. We have one skeleton.
Supposedly one.
Yeah. Where are they all? Where are all their skeletons? We have all their artifacts, lots of them, and we know where they lived, but nobody's ever found any remains of the people. So
there's supposedly one person found.
And that's the one in like Montana or something, isn't it?
Anzick 1. I can't remember where.
Yeah, it's called Anzick.
Anzick.
Yeah, but don't they have genetic connections to like South America or something? I'm trying to remember what. Again, this was in Graham's new book.
Yeah.
Well,
yes, you're right. It's Montana. It was found in south central Montana in 1968. It's a child that was buried with more than 115 tools made of stone, and antlers dusted with red ochre, suggesting an honorary burial, Anzick 1. But they found another skeleton in there called Anzick 2, which is like supposedly 2,000 years younger than that skeleton. So that whole site is just confusing.
Yeah. The thing is, we always look at this stuff based on what we would do. and how we would behave as if humans have always behaved the exact way we do.
Which is not a good way to do it.
No. That's why everything's a temple.
Yeah, that's right. Everything's a temple. And I was thinking, if the Clovis people did sky burials or something, we may never find really any remains.
Yeah, true.
Or if they did, burials by fire. If they buried their people by pyre, so you put them on a pile of wood and set it on fire, then there's nothing left but ash. So.
And not to mention, at the end of the Ice Age, you had, wholesale destruction of North America. So everything there was pretty much wiped clean.
Somebody had to have fallen in like a tar pit or the mud.
Right, that's right. Weird that there's just
you can't bury everyone.
Right. Unless you're Sam Squanch.
Wow.
Then you can hide everybody. That's every single one.
The thing too is that we're putting together the past based on such little pieces of evidence. And I don't think people normally think about that, but what we have is like less than 1% of what was there at one point. So we're taking the stuff that just happened to survive out of the past and trying to build a full picture with it.
Right.
Yeah.
Yeah. You have one piece of a 2,000 piece puzzle and you're like, it's of a tree.
Right. Exactly.
Yeah.
All right. And there's really very few ways that remains can be fossilized in a way that preserves them for an extended period of time compared to the ways that it can be completely disintegrated.
Right.
So it takes
extraordinary circumstances to preserve something that long.
And one of them is that, like, we do it on purpose. We dig a tunnel or put somebody in a cave or something like that. But just naturally, most of the time, remains vanish.
Yeah.
Never to be found.
That's right. Randall was telling us about he was looking into this with looking into the because there's so many mastodon and mammoth skeletons in North America and up in the Siberia and stuff, and he's looking at like how does this stuff get preserved? And he was looking at there was a big drought in Africa in the 80s, I think he was saying, and hundreds and hundreds of elephants died around dry watering holes.
Mm-hmm.
So there were just there were tons and tons of elephants corpses, and within 5 to 10 years they were completely gone. All the bones were scattered. There was just nothing left.
Yeah. Wow.
So you have to if you want to preserve stuff like that, you have to pick them up and then bury them in an anaerobic environment with no oxygen so that they can't be dissolved.
Right.
Yeah.
Well, I feel like, when we're looking at the past, like you said, it's probably a more than 2,000 piece puzzle. We have one piece of a 1 million piece puzzle, especially the further and further we go back. And then when we're looking out into space, it's like we're in a fishbowl, and the fish can only see what's in the room with it and make some inferences about what's maybe in the next room based on what's going on. And it's going, I got this. I've figured it all out.
Right. And not only that, but it's coming through and being weirdly refracted by the bowl. So
right, exactly.
Everything is all distorted and strange. Yeah.
So we're in this little pinhole of history, looking out at this endless universe and going, "No, we got this."
You need some 4D glasses.
All right. This one comes from Vice. NASA's solar probe found things near the sun that we can't explain. The fastest object ever created by humans has discovered intensely energetic rogue waves within our sun and detected solar wind speeds beyond what any model has predicted. Neither discovery was expected or can be easily explained, suggesting there are significant gaps in our understanding of the sun. NASA's Parker Solar Probe, launched in 2018, traveled closer to the sun than any previous mission for several days last November and in April 2019. Scientists revealed the incredible findings from these first two close encounters from the swiftest spacecraft ever in a batch of 4 papers published in Nature on Wednesday. And this was, I don't have a date for this article. Though the sun is the center of the solar system and its radiation has nurtured life on Earth, it's one of the most unexplored objects in space because of its intense heat and radiation. Really? Huh, imagine that. During its 2 encounters, Parker traveled within 15 million miles of the sun's surface, far surpassing the 25 million mile record first set by NASA's Helios 2 mission in 1976. Parker has also claimed the title for the fastest human-made object in history from Helios 2, as it surfed near the sun at over 150,000 miles per hour. In a surprising discovery, Parker detected new phenomena within a quarter of an astronomical unit, the distance between Earth and the sun, of the solar surface. At that distance, the probe reported that the solar wind, which is a stream of charged particles emitted by the sun, was rotating around the star at speeds far beyond what models had estimated. To our big surprise, Casper said, by the time we got to our closest approach, the solar wind was flowing between 35 and 50 kilometers per second around the sun. That's something like 15 to 25 times faster than the standard model predicts. So we're missing something really fundamental in our standard models of the sun, how it rotates and how the wind escapes, and that's really interesting. Parker was also pummeled by a series of extraordinary intense Alphen waves in the solar wind. Interplanetary missions have long observed less energetic Alphen waves, which are ripples that flow through magnetized plasma from the sun. But Parker is the first to embrace the giant rogue waves near our star. Every now and then, suddenly within seconds, the speed of the wind would jump by about 300,000 miles an hour, Casper explained. Then for seconds or hundreds of seconds, the spacecraft would sit there, washed by this spike in the speed of the wind, and then just as quickly it goes away. These spikes are so violent that they distort and twist the magnetic field as they pass through it. It gives you a sense of just how much energy is in these rogue waves as they go by compared to the regular Alphen waves we've seen before. Though the mechanism behind these waves is still unknown, the sheer force of them might help explain two of the most persistent mysteries about the sun. Why is solar corona, the atmosphere of the sun, about 1,000 times hotter than its surface? And why does the solar wind suddenly accelerate to supersonic speeds at certain distances from the sun? Scientists suspect that an enigmatic process dumps heat and energy into the solar corona. The newly detected rogue waves might be a part of the dynamic. We're looking for buckets of energy. When we got closer to the sun, we're seeing some very large buckets go by, and that's good. In our initial analyses, they're definitely carrying a lot of energy, so they are very promising as an energy source. I'm not going to claim in any way that we've solved the mystery, but we have some surprising results to paint the path to closing this question. Parker's new data challenges long-held assumptions about the sun, which will lead to better models of solar storms that can affect Earth, as well as star evolution across the universe, plus the mission is just getting started. Now, again, jumping to the electric universe, they're saying that the sun behaves almost like a light bulb, where the center of the light bulb is actually cooler than the outside of the light bulb. And none of this stuff actually contradicts the electric universe idea.
Yeah, the waves are interesting. I've seen diagrams of them as think of a spiral kind of fan, or maybe picture if you put a sphere down into water and then you spun the sphere very quickly on its axis, where the axis was perpendicular to the surface of the water, you would get this spiral wave pattern in the surface of the water around the sphere, right, being caused by the rotation. Mm-hmm. Now, I'm not saying that these waves that they're detecting are being caused by the rotation of the sun, but it does spin once every 25 days or so, which is a pretty fast rotation for something that enormous. So it's an interesting dynamic that these sort of spiral waveforms are coming out of the sun and affecting the whole solar system. All the planets are being hit by them.
Yep.
And then it was also interesting that he noted that, there's this mystery about, you have a flare or a CME, a flare that releases some material from the sun, and that CME kind of comes up from the flare, and then all of a sudden it accelerates massively and gets thrown outwards at these enormous speeds, and it's like it's getting caught by these waves and being hurled after, so all very interesting stuff. That was a good sun probe update. Yep, we do that on our show. We've been doing sun probe up. So here we go, folks. Sun probe update. Where did the road go?
So I found the follow-up to that other article from livescience.com. Impossibly big black hole was probably impossible after all. 2 weeks ago, November 27th, astronomers published a paper in the journal Nature claiming they found an impossibly gigantic black hole not too far from Earth. So the problem is that the wiggling bit of light the researchers built a claim on, called that's not a letter, H with a symbol I don't know, emission line. Now it looks like it didn't come from a black hole at all. That means the mind-blowing mass measurement is likely wrong. You've got this high mass B star, and that's one component, and then the black hole is the other component, said Jackie Flaherty, an astrophysicist at the American Museum of Natural History in New York City, who wasn't involved in any of these papers. So why are they interviewing her?
This is one of our favorite parts of science articles.
So you've got, at least they admit she wasn't involved in them.
Right.
So you've got these two things that you're looking at, but they can't get muddled with each other. Telescopes in Earth aren't sharp enough to resolve the individual objects in star systems well enough to measure their movements, especially one of those objects is a black hole, only visible from the thin accretion disk of material around its main body. So studying these systems often requires analyzing the patterns and individual frequencies of light coming from the systems and using them to draw inferences about what's going on inside them. LB1 has a very bright data source, all the light coming off the normal B star in the system. Researchers can measure its movements using the Doppler effect, which makes light wavelengths lengthen and the light appear to redden as the star moves away from Earth, and then get a bit bluer as it moves back toward Earth. Researchers can track that Doppler effect in a series of emission lines, especially bright frequencies of radiation that correspond to individual features of a star. In the Nature report, the researchers found another emission line in the system, the H funny symbol line, that didn't seem to come from the normal star. They found it also showed a mild Doppler effect, suggesting its source was moving a little and hinting that it might have come from a disk of material around an unseen black hole in the system. What the new papers found is that the Nature researchers failed to fully disentangle the data from the bright source, the star, and from the dim source. The apparent wiggling in the H line was sort of an illusion created by the light from the companion star and disappears once you properly subtract that from source. Whatever's making the H line isn't moving at all relative to the system. Yeah.
That's too bad. They had to talk to somebody who wasn't involved in the study.
Yeah.
Because the people involved in the study were like, no, we're not talking to you.
Yeah.
Well, they didn't try. They just went to someone and went, hey, can you tell us about this?
Yeah. Nope. So what's the symbol? It's an H with a second line through it. Is that what you were saying?
No, it's a little symbol after the H that, like it goes up, makes a loop, and comes back up and crosses itself.
Huh. That's
the
the data sauce.
Huh?
That's the symbol for data sauce.
That's the spaghetti line for the data sauce.
I mean, I guess I could Google it and see what it says. But you would think, they would, if they're sticking it in an article, most people aren't going to know what that is. I'm guessing it's some kind of astronomical or mathematical symbol.
It's hard to grasp what they're trying to say about what the system is doing or about the error that the original researchers made without knowing what that symbol is talking about.
Yeah, exactly. And apparently I can't actually copy it and search for it inside of Pocket. I have to open the article. Hopefully nothing will start playing off the page. The nice thing about Pocket is you don't get all the pop-ups and ads, but once I have to go to the page, you never know what's going to happen.
Yeah.
Yeah.
The floating video player that keeps moving the text out of the way when you scroll and you're like, wow, lost my place.
Yeah.
Okay. So on the page, it actually looks like HA, but it's not. H alpha is what it means. A specific deep red visible spectral line in the Balmer series with a wavelength of a bunch of numbers. It occurs when a hydrogen electron falls from its third to second lowest energy level.
Microwave.
Yeah. It's a microwave.
So, but again, it tells you how subjective and how not specific this data that they're basing these ideas on, and then they're announcing them as discoveries.
I was just thinking when you were talking about it, they've got this complex system, and that article actually says, it's difficult. You can't actually see individual objects, and they have to make inferences based on like light that's coming from the system. So like if you've ever seen like off through the woods in the dark, a bunch of lights moving around, and that there's people over there with flashlights. So you can see their lights moving around, but you have no idea what they're doing. They could be building a fire. They could be setting up a tent. They could just be hanging out and drinking beer. You can't really tell by watching their headlamps move around in the woods. But that's what these astronomers are trying to do, sort of. Right? That's kind of an analogy. So you've got a bunch of dim lights way far away, and you're zooming in on them, trying to figure out what's happening in that complex system based on the movement of these lights. So and it's interesting. Like there's somebody there that's basically saying these guys didn't really resolve all the data. Yeah. And they made some inferences that they don't think is correct. So still up in the air.
Let's do one more. DailyMail.com. Thousands of artifacts discovered at a 12,500-year-old site in Connecticut. An ancient settlement that dates back 12,500 years has been uncovered in Connecticut that once the home to southern New England's earliest inhabitants. Maybe. The site was discovered by the Department of Transportation while constructing a bridge over the Farmington River in Avon. Archaeologists found an open fire pit and a number of posts from temporary housing, along with 15,000 artifacts that were mostly primeval tools. Catherine Labadier, staff archaeologist with the State Historic Preservation Office, told the Hartford Courant, "This is a once-in-a-lifetime opportunity to look at a site of this age in Connecticut. This site has the potential to make us understand the first peopling of Connecticut in a way we haven't been able to. The site is located near Old Farms Road." It says the site is located near Old Farms Road Old in Avon and dates back to a time known as the Palladinian period. One of you probably knows how to say that.
I don't know that.
Don't know that one.
Paleo-Indian period.
That's Paleo-Indian.
Paleo-India. Okay. The archaeologist involved in the excavation is named it in honor of Brian D. Jones, the state archaeologist who died in July. The features are remnants of what the team calls human activity. They include holes and walls, with senior archaeologist Dave Leslie described as traces of behavior that have been recorded in the earth. Archaeologists also found an open fire pit or hearth and a number of posts for temporary housing. The site shows evidence of the earliest known population in Connecticut. Doesn't mean it was the earliest.
Yeah, I remember looking at that article, and what was it, 15,000 artifacts they claimed?
Yeah,
and I was looking for pictures, and there's like one picture of a couple of extremely rough chipped stones. I'm just like, come on. I wanted to say, you got 15,000 artifacts, and this picture is the only one, and they're not even like well made. And of course, it was peddling the same Clovis first idea, and I was just like, man, this is.
Yeah. I mean, it's evidence that people were there
12,000 years ago. Yeah.
Right, but it doesn't mean that they were the first.
Right, but that's what I'm saying. They say that because of the Clovis first idea, and that's like the what is it? The marker. Clovis started around 12,000 years ago. So
yeah.
It's just strange, there's all this other evidence coming out, like the other story you read about the
Seriah Mastodon site. Yeah.
Mm-hmm, mm-hmm.
And they're still
talking about the first people that
Yeah. I tried to find more information about the dig, and just all it was like, I think they haven't published anything about it yet, like in scientific journals. It's just news,
somebody was building a road or a bridge or something, and we found, and so
they started excavating and they found stuff,
and they found wooden posts. That's interesting. So whoever these people were building structures. They were not completely nomadic either. That's also interesting.
Yep. I did have one other I wanted to read. Aliens definitely exist, and they could be living among us on Earth, says Britain's first astronaut. From CNN.com, and I think a few other places carry it. The thing about this article is that's not exactly what she said. Not the way it kind of like the headline suggests.
Yeah.
It's sort of two different things. She says she did say that aliens exist. There's no two ways about it. There are so many billions of stars out there in the universe that there must be all sorts of different forms of life. Will they be like you and me, made up of carbon and nitrogen? Maybe not. And I mean, that's saying we've been saying on this show forever, like we have the idea of sentient life down to just a very basic form that we're familiar with.
Black holes are alive, man.
and then she says, it's possible they're here now and we simply can't see them. So when you look at that idea versus the way the headline suggests that she's saying there are aliens among us, where she's saying that, life could be taking all these different forms and they could be right along with us and we wouldn't even recognize them. Not, they're walking around like aliens dressed as humans on Earth.
Right.
So, I mean,
what is she suggesting? What is she suggesting in terms of we wouldn't recognize them, like as in they're here or they're out in the universe and we wouldn't recognize it?
She says that in a tantalizing theory that you should probably make you very suspicious of your colleagues, Sharman added, "It's possible they're right here now. We simply can't see them."
Interesting. Okay, so they may be like electromagnetic forms or something like that.
Right, exactly.
Okay, all right.
She also had a lot of frustration in the, she said that she is, how did they put it? Her frustration with observers defining her by her sex. People often describe me as the first British woman in space, but I was actually the first British person. It's telling that we would otherwise assume it was a man. And she's right.
Yeah. Yeah, that's right. That assumption would probably be made if they didn't say woman.
Yeah.
Right.
Well, but even by saying woman, you're suggesting that there was someone, a man was there first.
Yeah, I get that too. Yeah.
Can't win.
No
matter what.
Well, I think if they had said she was the first British person, that would then suggest that she was also the first woman, but the first, British person. But by defining it as first British woman, it's like saying, well, British men have been up there, but she's the first British woman to do it. And that's an understandable frustration.
I thought you were saying that if they just said the first British person in space, then people would assume it was a man.
Yeah.
So that's why I can't win.
Well, they're describing her as the first British woman.
Right.
Which is not inaccurate, but she's like, I'm the first British person, not just the first British woman.
Yeah.
There's that sort of male bias that things like this are always done first by men.
Yeah.
And we don't necessarily think about it. So when you write it like that, it suggests that men have been there first, but she was the first woman.
Yeah.
But like that whole article, and that's on CNN, I mean, it's kind of taken out of context to make it sound more sensational than what she's suggesting. She's just kind of leaving this open possibility that, there could be life out there that's visiting us that we can't even recognize as life. And that's, like I said, that's something I've been saying all along. Like we say, well, there's no life in our solar system, but how do we know? How do we know there's not life on the sun or in the depths of Jupiter or something that's so unlike life as we know it that we would never recognize it?
And I mean, are viruses alive?
Yeah, that's another question.
How many of them come from space? We know that like the Earth there are viruses constantly falling inwards from the upper atmospheres. How many of them?
They're living among us.
So, I mean, but I think they pushed it more toward that sort of invasion of the body snatchers sort of headline, when in reality, she was just keeping an open mind to what constitutes life in space and alien life.
They made it clickbait.
Yeah, exactly.
Yeah.
All right. Well, that I think can wrap it up for right now. And where can people find you guys?
To go to look for us is brothersoftheserpent.com, our website. And you can find our podcast there where we talk about ancient mysteries and space weather news. We just had a great interview with Christopher Dunn. So,
which I need to go listen to?
Yeah, that would be great. It was a fantastic interview. So,
all right. Well, thank you guys.
Thank you so
for
much.
having us, man. We enjoy it.
Always a blast.
I would like to thank my awesome Patreons for all their support and all their help, and for continuing to help me make Where Did the Road Go a thing. So I would especially like to thank those of you pledging $10 or more: Tim, Allison Cook, Eric Hervin, Super Inframan, Rob Drummond, Alex Whitcomb, Nadine, Damian Tallman, Edu Camahort, Luke Osborne, Tactical Therapist, Janet Bunderson, 36 Dingo, Maria, Jennifer Campbell, American Rambler, Kevin, John Rutledge Foster, Eric Citron, Andy McNamara, Sasha Jorg, Matthias Sunby, Dominic O'Malley, Christopher Vaughn, Riker and Stark, Sean Cosgrove, Jose A., Roger Gonzalez, Craig Cicernos, Lindsay Jackson K., Alfred Tuttle, Kevin Schreck, Patricia Giaquinta, William Lovelace, Mark Brady, Chris is a hot dog a sandwich, and Carla Mahoney. Thank you all so very, very much. All right, I hope you enjoyed that. There's a Patreon extra segment. We had a few articles we didn't get to, and the Snake Brothers have a Mysterious Universe article to talk about days where the sun has gone dark that are unexplained. So that will be up for patrons later this week. If you want to become a patron, of course, go to the website, where'dtheroadgo.com. If you want to send us stories to talk about on the show, if you've had a paranormal experience, stories at wheredidtheroadgo.com is the place to send them. If you want to come on the show and talk about your experiences, we can arrange that as well. Same email address. And we'll see you next time. You have been listening to Where Did the Road Go? This show is made possible in part from our Patreons, and we thank you and everyone listening for helping us continue this exploration of the strange. You can always find everything Where Did the Road Go related at www.wheredidtheroadgo.com. And thank you so much for your support.